Relativistic dynamics. Introduction. Shown on the side is a tokamak, a device that stores ionized gases in magnetic fields that are heated in extreme temperatures to enable the fusion of hydrogen nuclei. This fusion reactor can change mass into energy, thus proving that energy can be both converted and conserved. In this lesson, we will explore how the fundamental quantities mass, energy, and momentum are dealt with using the principles of special relativity in ways that Newtonian mechanics has been unable to explain. The definitions and mathematical formulations of these quantities, which you have learned in the previous units, will be modified, if not completely reversed, to account for relativistic effects in varying reference frames. In this lesson, you should be able to do the following. Define mass, momentum, and energy using the principle of special relativity. Differentiate Newtonian and relativistic approaches in determining the mass, momentum, and total energy of a system. Solve for the relativistic momentum, mass, and energy of a system. So first we have the relativistic momentum. When we say relativistic momentum, it is a way that the conservation of momentum will hold in all inertial frames. Special relativity generalizes the idea of momentum such as that its conservation will become consistent with both relativity and Newtonian mechanics. Rest mass m refers to the mass of a particle that is stationary relative to the observer. A particle whose rest mass is non-zero, also called a material particle. We'll have a velocity and relativistic momentum equal to P is equal to m times v over square root of 1 minus v squared over c squared, where p is the relativistic momentum, m is the rest mass of the particle, and v is the velocity of the particle. Next we have the relativistic mass. Relativistic mass is a mass assigned to a body or an object in motion. Special relativity states that a system's net mass is the summation of the relativistic masses of the individual particles and not simply the summation of the rest masses therein. So the formula of relativistic mass is relativistic mass is equal to m over square root of 1 minus v squared over c squared. Relativistic work energy. The kinetic energy of an object is defined to be the work done on the object in accelerating it from rest to speed. In deriving a general relation for kinetic energy using special relativity, we have to take into account that a particle's kinetic energy is equivalent to the work exerted on it to displace it from its stationary position to a speed such that k is equal to w. The relativistic kinetic energy of particle is given by k is equal to mc squared over square root of 1 minus v squared over c squared minus mc squared is equal to Lorentz factor minus 1 times mc squared. The last one is rest energy. Rest energy is the energy equivalent to the mass of a particle at rest in an inertial frame reference. Integrating the relations of mass, momentum, and energy that we have discussed above, we can derive a general relation for the total energy of a system. The formula of rest energy is E is equal to K plus mc squared is equal to mc squared over the square root of 1 minus v squared over c squared is equal to Lorentz factor mc squared. Now that I'm done discussing the definitions and formulas of relativistic dynamics, the next reporter, Eliezer James Ahmad, will give you some examples to solve for the relativistic.
Hi everyone, my name is Eliezer James Ahmad and I'm going to talk about the relativistic dynamics. So, actually morning talaga ako nag-record para medyo okay naman yung pagkaka-record para maintindihan. So, mag-proceed na tayo sa solving. So, this is an easy solving. It's about we need to determine the rest energy of a 2.5 grams mass. So, actually, yung dapat talaga na maintindihan natin dito is ano yung value talaga or like, dapat natin isa sa maintindihan natin is ang exact value ng speed of light. Actually, ang exact value ng speed of light is 3.00 times 10 raised to the power of -8. Kasi 3 times 108 yan, meter per second. So, that's the value. As you can see here naman, naka-scientific notation siya. Okay? So, yung given natin is the 2.5 grams and the speed of light is 3.00 times 10 raised to the power of 2. So, madali lang talaga siya. As in, we need to copy the equation. T is equal to mc squared. And then we need to substitute lang. 2.5 yung given natin kanina. Yung given natin na 2.5 grams. 2.5 times 10 raised to the power of -3. Kasi, and then, we need to multiply lang by the speed of light. So, use the causes. So, if nakuha nyo na, actually, ang magiging answer na dapat yan is like, E is equal to 2.25 times 10 raised to the power of 14 kilograms meter per second squared. Kasi ang rest energy niya is 2.5 grams is equivalent to actually ang answer niya is 2.25 times 10 raised to 14. And then we need to be precise na dapat tama atong sign na imbutang like para sa volts, sa may ampere naman paggagamit ng ohms na. Pero dito we need to use the joules. So I know sorry. We need to use kay say 1 is equal to 0 talaga. Sorry na mali. Okay. And then so it also ang tamang answer niya sa answer na ito is tamang pagsulat sa answer is 2.25 times 10 raised to the power 14 J. Okay? So, proceed tayo sa example number 2, the average. So, here's the question. An electron has an extremely small rest mass of 9.1096 times 10 raised to the power of -31 kilograms, approximately 2,000 less that of photons. So, determine the magnitudes of momentum when the particle is moving at so we have the two options talaga ito. Kailangan natin answer is 0.015 speed of light. Actually, C is meaning of the C is speed of light. And then 0.87 speed of light. So, first, we need to kunin natin yung mga given example natin na dapat answeran. So, sa A is 0.015 and sa B is 0.87. So, as you can see here, dapat di talaga kayo malito. Kasi madali lang talaga siya. More on substitute lang tayo and then multiply lang. So, the rest mass of an electron is 9.1096 times 10 raised to the power of negative 31 kilograms. And the two velocities of each and 0.16 c and v is equal to 0.87 c na given. So, actually, speed of light ako. Diba? Nagsabi ako kanina. 3 times 10, 3.00 times 10 raised to the power of 8 meter per second. So, excuse me. So, actually yung pagbasa nito is like, every letters na nakalagay dyan is may meaning. So, iproceed nga tayo sa meaning. So, K is the relativistic kinetic energy, and is the rest mass of the particle. C is the speed of light in free space. V is the particle speed, and actually yung Y na logo na to is the Lorentz factor. So, Lorentz factor is equal, so actually solve natin yung number 1 muna. So, kasi sa upper na to. Sa pagka-step 3 tayo. So, Lorentz factor is equal to square root 1 minus 2 b squared to c squared. And then, we need to substitute lang. Madali lang siya, guys. Actually, pwede siya sa type sa calculus. I recommend na magamit ka ng calculus. So, substitute lang na 1 minus over 0.015c squared. Kasi naka-squared tayo ganina doon. Over c squared. I-copy lang natin yung c squared natin. And then, pagka lalabas yan sa calculator o sa scientific calculator natin, 0.999775. O, diba? Madali lang siya. Puro substitute lang tayo. And then, sa next, yung sa number 2 na natin, yung AB yun, diba? Kasi A tayo ganyan, ngayon B naman. So, ganun pa rin mangyayari. Substitute lang. 1 minus b squared over c squared is equal to square root 1 minus 0.87c squared over c squared is equal to 0.493,052. Diba? Substitute lang tayo. Magdadali lang ito. So, ang next step na natin is substitute yung mga given value. So, baka nagtataka kayo kung asa nagkukuha. So, kanin P is equal to 0.9975 multiply. Ito yung given value natin kanina. Dito. Ito. Sa 9.1096 times 10 raised to the power negative 31. Ayan yan. Multiply tayo balik. Multiply tayo. Yung answer, multiply natin sa given. And then sa question. Sa question natin na yung B niya, yung speed of light na 0.015. Multiply lang. Yung answer, multiply sa given. Multiply sa given question niya na dapat answeranan. And then sa speed of light. Diba? Madali lang siya. Puro multiply lang tayo. And then sa question number B naman, sa letter B, karoon lang. Answer, given question na 0.87 speed of light. And the speed of light na value. So, diba? That's all. Puro multiply lang naman tayo. And then, the answer na sa A is 4.10 times 10 raised to the power negative 34 kilograms meter per second. And then, sa question number 2, it's like 1.17 times 10 negative 22 kilogram meter per second. So, the magnitude of momentum nila, ang dalawa, ay yung answer nila. Diba? Madali lang. Average na na question. So, madali lang talaga intindihin yung physics, guys. So, we will proceed na sa key points. So, special relativity is also the generalized idea of momentum such that its conservation will become consistent with both relativity and Newtonian mechanics, while the rest mass, or m, refers to the mass of a particle that is stationary relative to to the observer. A particle whose rest is non-zero is also called material particle. As you can see here naman na when v is less than the speed of light in a free space, the equation is nearly equivalent to v is equal to mx of v as v increases the approaches speed of light. The system momentum approaches infinity. So special relativity proposes the system's net mass is the summation of the relativistic masses of the individual particles and not simply a summation of their rest masses therein. So when the particles b approaches the speed of light c, particles kinetic energy approaches infinity. When b is way smaller than c, so this equation, guys, becomes the nearly equivalent Newtonian equation for the kinetic energy. Now K is equal to 1/2 mv squared. So a particle's kinetic energy may be defined as the difference between the total energy, and E is the energy term as mc squared. When K is equal to 0, such that particle is the stationary famous relativity equation of the E equals mc squared. So as you can see here, this is the formula of our relativistic momentum, relativistic mass, and also relativistic kinetic energy and total energy. So I guess that's all. Thank you for listening for this relativistic dynamics. My name is James Aman, and my partner is Karen Pegal. Thank you.